Hello class, we're going to cover 4.5 exponential and logarithm equations today. You all have your notes, so what you can do is fill these things in as I go along, just like you just like you would if you were in class, if I was there in class. So first thing is we need to talk about, review a couple of things. Number one right here is the property that I gave you in 4.2 when it dealt with exponential functions. Remember the rule. If you have exponential functions, says that if I have two exponential functions and they have the same base, if they're equal to each other and they are the same base, we could set the exponents equal. So that's this rule right here that says if the exponential functions are equal to each other and they are the same base, we can set exponents equal to each other. Okay. Now, a new rule that I'm giving to you today is the logarithm rule to deal with logarithm equations. Okay. And it says that if I have log of a base on each side, so look, log of a base here, log of a base here, they're exactly the same, then we could set the function values equal to one another. So this is where this rule comes in at right here. Okay, let me say it again. If you have log of a particular base on each side of the equal sign, then you can set the function values equal to each other. Now this will apply a little later when we do the type 2 logarithm equations to solve. Now, real quick, let's review type 1. So we're doing type 1 logarithm as well as type 1 exponential. Okay. Remember, we want to find the same base on each side. So let's start off. Number 1, I have 3 raised to the x equals 243. Now, 3 is already a base here. We want to know, can 3 be a base on the other side? Well, yes, it can. So we write 3 raised to the x equals, if we're going to make 3 a base on the other side, then it would be 3 raised to the 5th power. Now, remember what I just said. If you have 2 bases that are the same on each side of the equal sign, then we can set the exponents equal. So now, because the bases are the same, we could just say x equals 5. And we've solved this. Number 2, we have 5 raised to the x minus 1 equals 1. Right now, we have a base of 5, and then on the other side, it's 1. We would make this a base of 5. Let me show you how. This stays as 5 raised to the x minus 1, but anything raised to the 0 power equals 1. So I can change this 5 to the 0 power. Now we have the same base on each side, which is 5. We can now set exponents equal. So x minus 1 equals 0. And when we solve this, we will get x equals 1. Now, look at where your x is. Your x is here. Your x is here. That's in the position of an exponent. So that could be negative or positive. Okay? That is exponential. The first two is type 1 exponential. Now, let's do type 1 logarithm. Okay? Remember, we did this in 4.3. If you're solving a logarithm equation, you have to turn it into an exponential function. Then solve it. So let's do it. Everybody should recognize here that my base here is e. When it's ln, because so it says ln of x minus 1 equals 1. That's e. My base is e. So e raised to the power of 1 equals x minus 1. Well, anything raised to the power of 1 is just itself, right? Remember, you all, e is like pi. It has a value. But instead of writing that value, we use the letter e. Now, how would you solve for this, for x? we would have to add 1 to each side. And we leave it just like this, right? But remember I said you have to check this right here. You have to check function values. You have to check function values. And you need to see if I plug this expression in right here, if you plug this expression in, will it keep it positive? Because that's where x is. X is in the function value and has to stay positive. So if I plug this in, the ones will cancel and just leave me with E, and we know E is positive. So this is my final answer. Next one. We got to write logarithm equation into an exponential. Base raised to the exponent equals function value. So our base here is 2. Raised to the third power equals x plus 1. Now, 2 cubed is 8 equals x plus 1. Now, everybody should say that we would subtract each side by 1, and we get 7 equals x. But we won't make that yet because look at where x is. X is here. And remember, anything in this pushing got to stay positive. Anything in this position, has to stay positive. So if I plug 7 in right here, 7 plus 1, that will keep it positive, okay? So 7 is my correct answer. This is just a review of type 1 exponential and logarithm equations. Simple.